Okay, it's a review today for our first test. It's on chapter 1. What was the chapter about? Pretty much notations. So everything that we did kind of had a theme of notations, whether it was probability, it was about, talking about intersect or union, etc. So I'm putting this up on my second screen in class, which won't be on the recording, but if you want to keep referring back to it, these are the topics that I want to talk about with you today. Notation, 3 forms of notation. So for instance, if I just said the numbers from 2 to 5, where it can be 2, I'm not on purpose making any particular notation here. It can be 2, but it can't be 5. That is not any notation known to man, but I kind of just did some chicken scratching there. You can now tell me what are the 3 official ways that you could write that. 1 is with a number line. 2 is with let's use set notation. And the third way is with interval notation. See if you can write it in those 3 ways. Something this easy would be like an R2 question. As in, if you're a freshman here, it's one of the easy kind that you need 3 out of 4 of the easy kind to 3/4 of them right to get an A, or to have a chance at an A. And then you need to have some hard ones right too. All right, I'll pause while you write this in the 3 different ways. And I'm going to set up groups here too so you know who you're checking with today. Okay, we're back, and I am now doing the 3 forms. I'm going to do a number line first. That's the easiest. From 2 to 5. You can circle both of them, but which one needs to be filled in? The 2, because it works at 2. And then I add it to shade, and there we go. It's a number line form. For the fancy pants form, it's X, where X is between 2 and 5. That's the way I always start. So the smallest number on the left, bigger number on the right. And then I have to put in my symbols. Now, if you reverse those, put the bigger number on the left, I will have to mark it wrong. It needs to be small, and then the variable, and then the big number. Okay, so then that implies usually you're going to be using a less than or equals, or just a less than sign like there. And then I need to close the set. Any part of that missing would mean you'd get it wrong. So be really, really careful. You don't want to lose points for the easy stuff. Okay, and then the last thing is just from 2 to 5, where 2 works, bracket. 5 doesn't work, parentheses. Raise your hand if you have that one right. Okay, good. Any questions on those 3 general types of notation? Yes, sir. On the side, you need to have these squiggly lines. I'll understand if they are not beautiful, okay, but they need to be brackets. If you wanted to have them perfect, it looks something like that. Okay, looks like a bird, sort of, if you put an eyeball in here. Anyway, so I don't know. Here's a seed that he's going to be eating. Anyway, however you want to think of it. I'm embarrassed now, so I'm going to go back and move on. So now let's talk about. Let's talk about that symmetry. Or it's actually a mix of the graphing, which is part 2, and the notation. What if it's a graph that uses set notation? It would look something like this: X, comma, Y, where, and this is a tough one because you're moved up now to the big leagues. 2 is less than or equal to X is less than or equal to 3, and Y is greater than 7. Ah, squiggle on the outside. It's terribly deformed, but all right. Give that one a try, and it's a graph. So give your best sketch of your graph. Compare it to the kid next to you. I'll pause for a second while I get attendance done. You have to erase the line. Okay, so here it is. I need to have 2 and 3, so here's 2 and here's 3, and it's between them, and those are solid lines because it says or equal to. And I would shade in between them. This is a very messy graph, but it's the idea anyway. And then it says greater than 7, and this is important, dotted line. If you had a solid line there, that's all it would take to get the problem wrong. And now it's greater than that, so you shade above it. And really, you want it's like an intersection problem. So if you left all of that, you get it wrong. The only where it intersects are the points that actually work. So it would be like that. Any questions about that one? All right. On the test, there will be graph paper, so you'll have to have this, be in the right spot. At 7, of course, is where it was going across there. All right. Any questions? Okay, that was set notation with graphing. Now let's talk some more about symmetry and intercepts. So I could say that this has, what's the kind of symmetry this kind has? Remember? It starts with an O. Origin. I could say it has origin symmetry. I could even make a picture of it and say it has origin symmetry, but I would get it wrong. What do I have to do to show? How do I show that? Yes, I have to have this memorized. Negative x comma negative y has to go in, and it has to come out the same as x comma y. So would you please prove that right now? Just like we did yesterday. That's half of what you need to prove it right there, just writing that little thing. Negative x comma negative y has to go in and be like x comma y. What that's really saying is if you have a point, like let's say 2 comma 8 up there, that there would have to be another point down here, like negative 2, negative 8. But you can't do it by sticking in an actual point. You have to use x and y and show it analytically. So what we're looking for would be something like this. I rewrite this, except I put a negative y in for y and a negative in for x. And I get negative y is equal to negative x cubed, because negative x times negative x times negative x would be negative. And then I have to divide by negative 1, y equals x to the third. Yay, it simplified down to the exact same thing as it started with. That is the proof that this has origin symmetry. Gentlemen, not now. You're in the front row. Very distracting. Okay, so this is origin symmetry. Would you just prove that this either does or doesn't have y-axis symmetry? Check for y-axis symmetry. Okay, so you were testing it for which axis? Y-axis. Okay, if you want to check for y-axis symmetry, you need to have a negative x. It's kind of counterintuitive. Okay, to check for y-axis symmetry, you use negative x. All right, so now I'm going to see by plugging in a normal y, see, and a opposite of x, y equals negative x squared plus 2 times the negative x. And this is going to be y equals, that part does come out the same. This part will be a negative 2x. The only difference between this and this is that little negative sign right there. Is that enough to make it non-symmetrical? Yeah, it has to be perfectly exactly the same. So this one does not have y-axis symmetry. If I wanted to test for x-axis symmetry, of course, I would use x comma negative y. And you'd find that it also doesn't have that. All right, so bottom line, you need to be able to test for all 3 kinds of symmetry. You also have to be able to recognize generally what they look like. Does that have symmetry? If so, what kind? Y-axis symmetry, okay? And what's the equation for something like that? Yep, x squared. It could be that it's, like x squared. Whoa, alignment's off, sorry. X squared, it could be shrunk down, could be moved to the right a little bit by accident, but all right, so what's the equation for one of these? Do you remember that? X equals y squared, very good. And that one comes out to have what kind of symmetry? X-axis symmetry. Now, I'd like you to, I want to see how many of you can accurately solve that for y. Don't just slap the answer together, you'll get it wrong. Solve for y. What would that equation be as a y equals? Try it. Not that hard. People that had me last year, you better dang well get this right. I showed you this. All right, so if you're going to solve for y, I heard a lot of people say, well, you just take the square root, right? You go square root. That is true. But here's the trick. When you do the square root of y squared, what do you get? absolute value of y is correct, equals the square root of x. Did you know that? Those of you that are in honors pre-calc, that's a really important thing. Because if you think you only get one answer out of this, that y is the square root of x, you missed a whole answer. Y equals the square root of x, and there's another one. Because this is in absolute values, you have y equals the square root of x, and you also have y equals negative the square root of x. Why? Because the square root of x, do you remember that equation? It just goes like this. I don't have the whole bottom part. To get the bottom part, you need the negative square root of x. Here's another reason that that's important. Because if you have this, and you just think, oh, I can just take the square root of both sides, and the answer is 4, you will lose a lot of points in this class. Because there's two answers. 4 and what? Negative 4. And the reason is, when you go square root, you get the absolute value of x. Some of you guys, I think that the square root of 16 is 4 and negative 4, and it's not. The square root of 16 is just 4. You've got to clear up that misnomer. A lot of people think the square root of 16 is two things. It's not. The reason you get two answers is because the absolute value sign's here. So then you make 2x equals 4, x equals negative 4. I mean, if you ask your calculator what's the square root of 16, it's not going to say plus n minus 4. There is only one square root of 16, and it is 4. Okay, the reason there's two answers is because of the absolute value. Another example of that is in the top 20, and it comes in something like this. And you take the square root of both sides, right? And a lot of people go, okay, square root, x minus 3 equals 5, because that's the square root of 25, and they're wrong already. Because when you did that square root of a variable, you needed an absolute value here, and then you can make two parts. X minus 3 equals 5, x minus 3 equals negative 5, and you solve both. Because an absolute value here, what's underneath the scribble, has to be either 5 or negative 5. That's why we do it that way. That's another top 20, something a lot of kids don't know that you will, and hopefully you'll remember it. Add 3 to both sides, x equals 8. Add 3 to both sides, x equals negative 2. Two answers. You don't want to buy x and then drop an answer. You'll lose a lot of points. Okay, moving on. Let's talk about intercepts. These are some sample problems that you can do for practice at home if you would like to, but we don't have a review sheet for you. That's a really important point here. The review sheet is all the problems that I've done with you so far. All these problems, they have been preparing you for the test. You have to be able to go through your notes. That's what happens in the real world when you're studying for a science test in college, is you have to look through the notes, because whatever the professor talked about is usually the important stuff. Now, the really evil professors will talk about stuff, and then they won't even put that on the test. They'll put the other stuff from the book on the test. That's not going to happen here. Okay? At least you're going to have what I talked about. That's the stuff that you should know. Am I telling you absolutely everything? No. This is an honors class. You need to be able to, like, stretch your brain a little bit to have a new situation slightly on the test and go, oh, okay, I can apply this. I can do this. Not a lot of that, but there's going to be some of that. All right, because like, for instance, on that quiz you took, you remember when it was Sasquatch has been spotted this many miles each? We didn't say the point was -5, -12. You had to figure out, oh, if he's 5 miles east and 12 miles south, then he must be at -5, -12. You had to put that together, right? So, same idea on the test. Not everything's going to be totally easy, but then again, there's only 12 questions on the test, and you'll have all hour. All right, so let's move on to finding the intercepts. If I said I had this, and I wanted to know the y-intercept of it, it really isn't very hard if you know the little rule. The y-intercept is where what? X equals 0. Use that and figured it out. And then figure out for me what the x-intercepts are. Find the x-intercepts and the y-intercepts. And in a moment, I'm going to have you compare with the person across from you in rows 3 and 4 and rows 1 and 2. Find the x-intercepts and the y-intercepts. If you haven't already check with them quick. See what they think the x and y-intercepts are. If you totally forgot, I'll show you in a second. Okay, so the y-intercept is where x is 0. I just put a 0 there, and this cancels off, and it's just y equals 3. Done. And if you want to put a point for that, it'd be what, comma what? 0, comma 3. Okay, that's the y-intercept. Yes, question about that? Yes?
Well, if it's 0, why doesn't y times 0 make y 0?
If it's 0, why doesn't y... what?
Well, it's y times x squared, so why wouldn't it be y?
Oh, I see what you're saying. I see what you're saying. Okay, how about this? Let me start. Actually, it might be an asymptote. That's a good point. I used a weird equation this time. It might be an asymptote line. All right. You know what? I apologize for that. The reason I did this one is because of the next one that we're going to do. So let me, actually, that's also going to be an asymptote line. I apologize. Sorry. Let's try a different equation. Okay. Y-intercept, x-intercept. The other one isn't impossible, but it's outside the scope of what we've done. So I'll show you the other one in a minute. I want to first get this one down so you know a normal one, and I'll come back to the weird one in a second. All right. So the y-int and the x-int. So the y-intercept is where x equals 0. Put a 0 there. This becomes 0. 0 plus 7, y equals 7. Okay. And the x-intercept. The x-intercept is where y is 0. And so that would mean this one, I put the 0 here now. And now how do I solve that? I subtract 7 from both sides. And, oh, I got another weird one. Does anybody know why? You're going to do square root of a negative. So it's not a real number again. Oh, yay. Don't worry, on the test we're not going to mess with you that way. Okay, so then this is divided by 2, and then it's square root of, and then hopefully, the reason I did it with a squared like that is so that we could talk about how it has to be a plus and a minus. But when there's a negative underneath the square root, that means that there is no solution. Are there graphs that are actually like that? Absolutely. Let me show you one. If we went like this is a square root graph. Do you remember it from higher algebra?
Yes.
All right. Tell me what its x-intercept is. Doesn't have one. What's its y-intercept? There isn't one. Okay, so the point is there are answers like that. But let's go to that one that I gave you originally. And when you have something where it's divided by 0, like say I divide by x squared on both sides. Okay, this cancels. Now what if I stick in x equals 0? What is 3 divided by 0? Undefined. If something is undefined like that, it's usually an asymptote on the graph, meaning like it gets closer and closer to that and never touches it. Or it could also just be in an area like the one I just showed you, where it's over here somewhere and it's not defined. There is no square roots of negatives, so you can't have an answer over there. All right. The main point is, do you know that the x-intercept is where you set what? Y equal to 0. And the y-intercept is where you set what? X equal to 0. Good. That's the main thing there. Symmetry, we've already talked about those little rules for origin symmetry and those kinds of things. Did we do practices of those already this hour? Okay, good. Just making sure. Then let's talk about these kind with the shading. Let's say it's A and B and C, and it's this and this and this. Would you please make one of those and try to tell me where A not union B would intersect with C? I'll pause for a second. Let me give that a shot. So here's how you think this through. First of all, not A. Think of A as like the sun, and not A are all these rays that are not it. Okay? Then union with B. Union means that if you're invited by the first thing or the second thing, you get to come. Well, the B is all of this, and the only thing that's going to add to the little group is this little wedge of A, which wasn't originally invited, but it got invited by B. Okay, so now all of that is being shaded. Now I've got to intersect that, as in where's the overlap, with C. Okay, for this part, I'm going to only shade in the part that overlaps. Even though I know the full C circle would apply, I'm just going to shade in the overlapped part, which would be like this. And I hope you get that you can't leave all that shading in there? The answer is just the black area. So what I'm going to do is remove the other areas here like this, and then put the black area back in there and say there is the final answer. Raise your hand if you had the same thing as I did. Okay, awesome. If you need more help on that, it's okay to say, can you do another one like that? But you'd need to raise your hand and have the guts to say that and do that. All right, so let's move on to distance and midpoint. Fairly straightforward if I just tell you the points. We might tell you the points in a creative way. There's a point, and here's a point. Would you please figure out the distance and the midpoint between those 2 points? 2 separate questions, distance and midpoint. I'm going to pause while you give that a shot. I hope you remember how I had you visualize the distance formula. It was a house in this dark, scary area of town. When you walk in the house, and what is in there? X's are fighting in a square, and then what? Y's are fighting in a square. And the only thing that's kind of like has to stand out in your mind because it's unusual, what was between those two? A big plus sign. Okay, good. So that's the house and the X's fighting in a square, and the Y's fighting in a square. And I'm telling you, that's going to stick in your mind much better than the average formula because you have a visual for it instead of just a bunch of letters. All right, now do you have to have this? Well, not really, because it doesn't really matter which way you subtract them because you're going to square it. So 2 minus 5 or 5 minus 2 isn't going to matter because you're going to square it anyway. All right, so in this case, the X's, when they fight, X and X, holy cow, they make a 0. That implode the whole problem? No, just 0 squared is 0. So I have square root of 0 plus, then the Y's are fighting. Does it matter if I say negative 3 minus 9 or 9 minus negative 3? No, actually it'll come out the same. So if I go 9 minus negative 3 or negative 3 minus 9, either way, wait a minute. Yeah, that's right, because one's 12 and one's negative 12, but then I'm going to square it anyways, 144. And then the square root of 144 plus 0 is just 144, which is 12. Did you get that as a distance between these 2 points? Good. All right, now if you really think about that, it wasn't too hard because at 2 comma negative 3 and 2 comma 9, they're only that far apart, and it's a straight line, and it's the distance between the negative 3 and the 9. All right, last thought is a midpoint. The midpoint is the average X and the average Y. Well, the average of 2 and 2 is, surprisingly, 2. And the average of negative 3 and 9 is 6, and then divided by 2, 3, 2 comma 3. Did you get 2 comma 3 as your midpoint? Okay, good. And you're ready for that topic, should it arise. And next is probability. There's a lot of ways we could do probability. I'm going to give you a probability that involves a Venn. Now I'm going to see if you can piece it together. Here's A for apples, B for bananas. I'm not going to get super creative with it right now. And we're going to say that the probability of not banana is 0.7. And I'm going to say that the probability of A is 0.5. And I'm going to say that the probability of A intersect B is 0.1. 0.1. That should be enough for you to figure out all the probabilities that could be here, 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 and here. Then I would want you to answer a question about it, like, what is the probability that I would choose somebody who would be a not B intersect A? So first job is to make the probability Venn. The second job is to answer the black question about it. I'll pause for a second while you give that a shot. So if not B is 0.7, do you get that this and this together need to be 0.7? Okay. If probability A is 0.5, do you get that this and this together need to be 0.5? Again, I can't do anything yet, but now I finally have the key. A intersect B is 0.1, so that means this one right here is 0.1. Once I know that, then they kind of start falling into place. Probability of A, I do not put a 0.5 where this green question mark is. Together, they have to make 0.5, so that's a 0.4. And then, if the outside of B, not B, which is this one and this one, had to be 0.7, then this one must be 0.3. Do you agree with me so far? Okay, good. And then 4, 5, 6, 7, 8, that leaves 0.2 left for right there. That was like a little logic puzzle. Okay. Now, what is the probability of not B intersect A? Not B, I'm going to do the sun thing again. This is not B intersecting with A. So that's just this part right here, and that'd be a 0.4. Okay, now I'm going to make it more complicated. I'm going to say given. Given that the person, this is apples and bananas, given that the person likes apples, what's the probability that they do not like bananas? Given that the person likes apples, what's the probability they do not like bananas? Whenever you're doing a given, you got to say, oh, that's right, probabilities are fractions. All the things that are possible are on the bottom, and what I want's on the top. As soon as I said given not, what was it? Not bananas? Don't like apples? Don't like apples? No. What did they not like? Okay, thank you. If they did not like bananas, I know for sure these are out. Do you get that? Okay, so then it's 0.4 and 0.3, which makes 0.7 is my possible. And then the probability they liked apples, 0.4. I said it wrong. I apologize. Okay, what did I say wrong? Okay, I should have written it down. Given A, like I like apples. Is that what I said? Okay, how did I? Okay, so given I like apples, then I can only pick from these two. Now, what's the probability that oh, that's right, that I do not like bananas from there? Okay, given I like apples means given tells me what my denominator is. The only things that are possible then are those two, and therefore it's 0.5. Could you shut that door for me, please? And then what's the probability I do not like bananas? Not liking bananas is this and this, but that's not part of the possible, so I can't include the 0.3. So it's just 0.4 then. Now, do you agree with that one? Okay, I know that's a tough one. That's a tough one. Okay, that's probabilities and about as tough as it would get. And then the last topic there, relation graph. Don't worry, that's in next chapter. So I'm not going to be asking you to tell me about relations and functions. That's next chapter. Okay, now how does one study for a test when you don't have a practice test to do? There are some problems in the notes you can look at, but that doesn't mean that if you don't understand one of the problems that's there for practice, the person who was making those was trying to say the problems aren't always going to be what you have done exactly in the past. We want to be able to do problems with you and then have you do similar problems on the test that you hadn't seen before. I specifically tried to not do problems like the tests. They're going to be similar to what we did. Okay, if I just tell you all the problems ahead of time, it makes it way too easy in an honors class. All right, have a good day. Hope you study. Tomorrow's a test. We'll grade homework or collect homework in class tomorrow.